Some other things that the respiratory system is going to do: voice production. We have these cool little things called our vocal cords, these little vocal folds, all right? And as we have movement of air past those, that's going to help with the production of our voices. Olfaction, smelling, hopefully you guys remember that, okay? And for us to smell something, how, do you happen to remember what that little molecule has to do for us to be able to smell it?
Let's take it first.
Well, olfaction is for the nose.
But I thought it's like in the.
It has to be dissolved in, it has to be in the air. And then we have that olfactory epithelium and the mucus and everything. Do you guys remember that? Okay. So, another thing that this system does is with the production of the smells. Regulation of pH. What's that?
Acidity or basic.
How basic or acidic something is. Ooh, whoa, wait a minute, Charity. pH of what?
The blood.
pH of the blood. Wait a minute. How in this system could it affect pH of the blood?
The oxygen.
Huh? What?
The oxygen inside the blood cell.
Let's change that to the CO2. Because the CO2, if you guys remember, the waste product that has to be returned and we breathe out, when it makes it to the blood, we have to make sure, because if it combines with the water, and blood's what, 75% water? Okay? It forms carbonic acid. So do you guys remember how the body had buffering systems for it to travel? Okay? So, breathing rate, depth of the breathing, would that affect CO2? Yes. If we affect the CO2, we are going to affect the pH of the blood. Regulation of blood pressure. Holy cow. Does it end? There's going to be something that can get produced in the lungs called angiotensin that's going to be able to affect the blood pressure of the body. Wait a minute. Blood and lymph flow. What do I mean by that? Can't hear you.
The flow, blood and lymph again, gravity.
Okay, and so if we're having to do that, if we're having to get that material up, moving it against gravity, what are we doing it with in this system?
You're pushing the diaphragm, so it's
We are
allow the-
affecting that muscular movement. How was it that we depend on the flow of lymph and blood? What is it that we needed? The muscle contractions, okay? So every time we breathe in and we breathe out, we've got this skeletal muscle working. We've got this huge diaphragm, really, really cool muscle, okay? And we're changing thoracic volume, okay? And we're going to be able to help push these materials, which is kind of cool if you think about it, for breathing. When we breathe, we ventilate. Breathing is termed our respiration. Ventilation is moving the air in and out of those lungs. We are going to find that we have external and internal respiration. What in the world do they mean? The external respiration is the gases that we exchange from air in the lungs and the blood. Internal is what we're going to exchange from the blood to the tissues. The goal, moving oxygen and CO2. Those are the two gases that this system can deal with. That's it. But those two gases, especially the CO2, can affect every other system in the body. Don't confuse respiration overall, this ventilation, this moving in and out, this, okay, that we do with our cellular respiration. Are they related? Yes, okay, but don't confuse these respirations. As we begin to look at the respiratory system, this is probably what people think about. When we talk about the structure of the respiratory system, we refer to it as having the upper and the lower respiratory system. Ever heard people say, I have an upper respiratory infection? Okay. What part of the respiratory system, what area, what structures are they referring to? If they say upper, do what?
Anything above the trachea.
That's a good way to put that. Will you say that again?
Anything above the trachea.
Anything above the trachea. So when we say the upper respiratory system, this is going to be our nose, our nasal cavity, our pharynx and its associated structures, and the larynx. This would be upper respiratory tract. Everything below becomes the lower respiratory tract. Our trachea, our bronchi, our bronchioles, our lungs.
What about the diaphragm? Does that count in it or not? No diaphragm.
Not for the tracts, because the tracts are what is going to get the air to the lungs. Each one of these tracts has something that it does as we move the air. This system, now structurally, upper, lower. Functionally, two zones. Write that down. Functionally, there are two zones.
And structure was 2 tracks.
The structure has the 2 tracks. Functionally, we have 2 zones. The conducting zone and the respiratory zone. We've got the conducting zone and the respiratory zone. The conducting zone is for air movement. The conducting zone is for air movement. It goes from the nose to the bronchioles. Because we are moving air from the external here to these places in the lungs. The respiratory zone, this is in the lungs, and this is where we're going to see the gas exchange between the air and the blood. This is the gas exchange between the air and the blood. So if we look at this system, we think about our conducting zone. This is my upper tract, and it's part of my conducting zone. So if I look from the nose to the trachea, all right? One of the things that happens with air movement, we're taking in the air, is that correct? Right now, your normal body temperature, according to them, and everybody remembers who them is, right? Okay? According to them, should be what? 98.6 is the air that you are breathing in right now. 98.6. Okay? Any light bulbs?
Goes through the body, it warms up.
Okay, but my light bulb I wanted you to recognize is the body's got to do something to make that air accepted by the lung without it being a shock to the system.
Moistens it.
We have to cleanse it, we have to warm it, and we have to humidify it. And it has to be done before it makes it into these structures of the lower respiratory tract. Now, in the grand scheme of things, that's not a lot of room to raise the air's temperature before it hits the areas of the lung. So this upper respiratory tract becomes important because what we're going to see is that the parts that are going to make up this tract, all right, if we have the nares, the two holes, okay, the stuff the parts that you see people with their fingers stuck up, okay, and sometimes you wonder how are they not reaching their brain. All right, just saying, okay, so you got the two holes, all right, that are going to lead into this nasal cavity. We've got a vestibule, we've got a hard palate, we've got some septums, we've got some choanae that are in this area. Now, if we begin to look at this structure that's taking place in this nasal cavity, see how we've got these little flaps that are present? These are our choanae. You can see there are 3 of them, right? And they have an entrance right here before we begin our descent down the pharynx. These little flaps, when we breathe in, they're going to, well, first of all, we're getting exposed to epithelium. That's this mucus type membrane, okay? This mucus covering to it. And having those little choanae that are there, as the air moves past, the choanae flap. And as they do that, they're creating turbulence in the air. We have a very good blood supply to this nasal cavity area, and it's going to have the ability to warm, cleanse, and moisten the air.
The concha.
Yeah, these
Or
right.
Coae.
Well, the coenae and concha, because it looks like a
That's
shell
the
on
cleansing
a
and warming.
seashell.
And that's where the cleansing and warming happens.
In the nasal cavity,